Welcome to our YouTube channel Vidyar Kalai Vinmin JEE Main Examinations 2022 Physics Memory Based Solved Question and Answers. Please subscribe, comment and share. Question: two identical cells give same current across R resistance when they are in series combination and when they are in parallel combination. Find internal resistance of a cell. Here is the circuit number 1. Here is circuit number 2. Now the current flowing through the circuit number 1, that is current flowing through the R, is I, let us assume, and the same current is flowing through the circuit number 2, that is same current I is flowing through R in the circuit number 2. I hope you understand. Now the four options are R, 3R, R by 2 and 5R. Let us see how to find the answer for this question. From the circuit number 1, let us find the I. Let us go back. From this circuit, the current flowing through the resistor R, capital R, is I. How to find the I? I is equal to, here two cells are in series, so 2E. We can sum up the voltage 2E divided by its internal resistance R and another R, so 2R plus the capital R. This is the current flowing through the resistor R in the circuit number 1. This is for CKT number 1. This is circuit number 1. Now for the circuit number 2, this is circuit number 2, the current, same current I is flowing through the resistor R. How to find out I? Here E is the cells are connected parallel, so I equal to E divided by, these two resistors are parallel, so it is small r by 2 plus R. Let's see in detail. From the circuit number 1, I is found as 2E divided by 2R plus R. For the circuit number 1, this is considered as the equation number 1. For circuit number 2, I is equal to E divided by R by 2 plus R. This is for circuit number 2. This is considered as the equation number 2. Now what is given in the problem is current flowing through the capital R resistance is same. That means we can equate equation 1 and 2. So we get 2E divided by 2R plus R, which is equal to E divided by R by 2 plus R. Cancelling out the common terms, we get R equal to, cancelling and simplifying, as a result we get R equal to capital R. This is the resistance of the cell. That is, what is the meaning? The internal resistance of the cell R is equal to the external resistance R. This is the answer. So our option is A is the right answer. Next question. Electric potential varies as V equal to 3x square. Find electric field at the point having coordinates 1, 0, 3. Let's solve the problem. E equal to minus dV by dx. We know the value of V, that is 3x square. Substitute and differentiate with respect to x. We get E is equal to minus 6x. Here the coordinates are given as 1, 0, 3. X is equal to 1, y is equal to 0, z equal to 3. So we need only x. So E is equal to minus 6 volt per meter. E is equal to minus 6 volt per meter. This is the answer. Very simple formula, that is E equal to minus dV by dx. V is given, so we need to differentiate with respect to the distance x and substitute the coordinate x value. We get minus 6 volt per meter. Equation of a simple pendulum is theta equal to theta naught sine pi t plus pi. Find the length of pendulum. Option A 1 meter, option B 2 meter, option C 0.5 meter, option D 4 meter. Here from the statement we can consider omega is equal to pi. We know the formula for omega, angular frequency, that is square root of g by L. Squaring both sides, substituting the value of omega, that is pi, we get pi equal to square root of g by L. Squaring on both sides, we get pi square in the left hand side, and in the right hand side the square root is cancelled, so g by L. Here g is the gravitational force, which is 9.81. The value of pi is equal to 3.14. Substituting in the equation L equal to g by pi square. So g is 9.81, pi square is 3.14 square. As a result, we get L equal to 1 meter. That means both the numerator and denominator will have the same value. So L equal to 1 meter, that is the answer. The TV height of TV tower, the height of TV tower is 125 meter. This is the height. If its range is doubled for signal, find the new height. Option A 125 meter, option B 250 meter, option C 500 meter, option D 300 meter. Let's go for the solution. There is a formula, the range which is equal to square root of 2HR, where h is the height, d is the range. This is the old one. So the old height is 125 meter. 125 meter. H is given. So the new formula, this is the new formula, this is the old formula. D equal to square root of 2HR. And if the range is doubled, we get D becomes 2D. And the height, new height will be H dash. Now substituting 1 in 2, substituting 1 in 2, we get 2 into d, that is square root of 2hr, which is equal to square root of 2h dash r. Squaring on both sides, we get 4 into 2hr, which is equal to 2h dash r. Cancelling the common terms, we get h dash is equal to 4h. We know the height 125 meter. Substitute the new height of the tower for doubling the signal or range, we get 500 meter. That is the answer. The new height will be 500 meter. Next one, I equal to A by 5, R equal to 1 ohm. Find A. The options are 14, 8, 12 and 2. This problem seems like it's very complicated, but it is not like that. It is not very complicated. It's very easy. Once you know the concept, it is easy to solve this problem. So please attend such a problems. It will be easy. Now, how to solve this problem? Starting from the right hand side, moving towards the left hand side. So here R is parallel with another R. Like this, there are 4 combinations. R is parallel with R. Now, take the topmost parallel resistors. R is parallel with R, and simplify. When R is parallel with R, we get the equivalent resistance R by 2, because both values are same. If both values are same, the equivalent resistance will be decreased, that is R by 2. Now this R by 2 is in series with R, so you can sum it up R. And similarly the other combinations are, and in this branch we get R by 2 plus R. These two are parallel. Okay, let's go for the solution. It's very easy. Don't panic. Once you receive such a kind of question, don't panic. Try to simplify the circuit from your right hand side to left hand side, so that you can able to find the value of A. R is parallel starting from your rightmost end, in from the top to the bottom. R is parallel with R, so we get the equivalent resistance R by 2, and this R by 2 is in series with R, so we get R by 2 plus R, which is parallel with the other branch resistor R by 2 plus R, and simplifying we get this value R plus R by 2 the whole divided by 2, and resistor 1 by 2 R plus R by 2 is in series with R. Simplify, we get 3R plus R by 2 divided by R, that is 7R by 4, which is parallel with another 7R by 4. We get 7R by 8, and this resistor is in series with R. Finally, we get the equivalent resistance of the circuit 15R by 8. Now, according to the Ohm's law, this is the Ohm's law. Using the Ohm's law, I equal to V by R. We know from the circuit V is given as 3 volt. The equivalent resistance found as 15R by 8. Simplifying, we get 24 divided by 15R. Here, R is given as 1. Sorry. R is given as 1. Substitute, we get 24 divided by 15. Now, I equal to A by 5, which is the given data. Equating I with A by 5, we get A by 5 is equal to 24 divided by 15. From this equation, we can calculate A as 8. This is the answer. A is equal to 8. So our option is value find A, that is option B, 8. If resistance of a resistor is 2 ohm at 10 degree Celsius and it is 3 ohm at 30 degree Celsius, find the temperature coefficient of resistance. 4 options are given. Let's see the answer. First of all, we write the formula RT is equal to R naught of 1 plus alpha del T, where del T is the change in the temperature, that is final temperature minus initial temperature. Alpha is the coefficient. RT is given as 3 ohm, R naught is given as the 2 ohm. Substituting, we get 20 alpha is equal to 0.5. The temperature coefficient alpha is equal to 0.025, which can be written as 2.5 into 10 to the power minus 2. So our answer is 2.5 into 10 to the power minus 2. Option C. Two capacitors of capacities 5 microfarad and 10 microfarad connected, and the switch is kept open. Initially, potential on 5 microfarad capacitor is 30 volt and 10 microfarad capacitor is uncharged. Find the charge on the 10 microfarad capacitor once the switch is closed. 4 options are given, that is 300 microcoulomb, 100 microcoulomb, 200 microcoulomb, 400 microcoulomb. Let's find the answer. So from the problem statement, we can draw the picture or diagram. Two capacitor, in between the two capacitor, a switch is connected. Here is the switch. And initially the charge in the 5 microfarad capacitor is 30 volt. The charge in the 10 microfarad is 0 because it is uncharged, but the value is 10 microfarad. Once the switch is closed, C2 will be getting charged. So the formula for the voltage on C2 is C1 into V1 plus C2 into V2 divided by C1 plus C2. We know the value C1 5 microfarad and V1 is 30 volt, C2 is 10 microfarad, V2 is uncharged, so it is 0 divided by C1 plus C2. Substituting the values of C1, C2, V1, V2, we get 150 divided by 15, which is equal to 10 volt. Now the charge in the capacitor, 10 microfarad capacitor, the formula is Q equal to CV. C the value is 10 microfarad. V we found out 10 volt. So 100 into 10 to the power minus 6, which can be written as 100 microcoulomb. That is the answer. 100 microcoulomb is the answer. So our answer is B, 100 microcoulomb. In series RLC circuit, voltage across capacitance and inductance is twice that of resistance. If R equal to 5 ohm, V equal to 220 volt, F equal to 50 hertz, if L equal to 1 by K pi, then value of K is in millihenry, mH. 4 options are given. Let's find the answer for this question. According to the problem statement, we can write VL is equal to 2VR. Voltage across the inductor is twice that of the voltage across the resistor. So VL equal to voltage across inductor can be written as I into XL. Voltage across resistor I into R, where XL equal to L omega, substitute, cancel the I. So L we can write 2R by omega, where R is given as 5, omega is 2 pi F, F is 50 Hertz frequency. Substituting, we get L equal to 1 by pi into 10 to the power minus 3 divided by 10 to the power minus 3. Why we have added this term? Because 10 to the power minus 3 divided by 10 to the power minus 3 will not change the value of L. This is, our answer should be in millihenry. So we are multiplying and dividing by 10 to the power minus 3. L is equal to 1 by K pi. From this, K is written as 1 by L pi. Substitute the value of L. L is given here. Substitute the value, we get K equal to 100 millihenry. 100 millihenry is the value of K. So 100 millihenry we can write 10 to the power 10 to the power 2, that is option B is the right answer. Transistor work like switch in A. Active region, B. Cutoff and saturation region, C. Cutoff region only, D. Saturated region only. A transistor can be used as a solid state switch if the transistor is operated in the saturation region. Then it acts as a closed switch, and when it is operated in the cutoff region, then it behaves as an open switch. So from this statement we can find the answer B, cutoff and saturation region. In the saturation region it acts like a open switch, closed switch. Closed switch. In the cutoff region, open switch. So our answer is cutoff and saturation region. The transistor work like a switch. For the given, sorry, for the given, for the figure given, A is constant. Find value of M for which equivalent resistance is maximum. Now, how to find the value of M? Here, MA is the resistor value. 3 resistors are connected parallel. Here, A by M, 2 resistors of A by M are connected parallel. Now, first of all, we need to simplify this. 3 resistors connected parallel. So, we get MA 1 by MA plus 1 by MA 1 by MA plus 1 by MA plus 1 by MA, 3 resistor, and the equivalent will be 3 by MA. Similarly, A by M, 2 resistors are connected parallel, so we get equivalent resistance A by 2M. And these two are in series, so we can sum up to find the total equivalent resistance. Let's go for the solution. 4 options are given here. R equivalent is equal to MA by 3 plus A by 2M. Differentiating this equivalent resistance with respect to M, which gives 0. Now, after differentiating and equating to 0, we get A by 3, which is equal to A by 2M square. From this equation, we can able to find M as square root of 3 by 2. Square root of 3 by 2 is our answer. So our Answer is option D, square root of 3 by 2. For the Vt graph, we can say pressure P1 is less than P2. Option B, P1 is greater than P2. P1 is equal to P2. No relationship can be obtained. Let's see how to solve this problem. Or we can redraw the diagram, the relations between V and T, starting from the origin. Now, there is a formula PV equal to nRT. PV equal to nRT. From this formula, we can write V by T. That is the ratio between V by T, which gives the slope nR by P, which is the slope. So slope is equal to nR by P. Here slope is inversely proportional to the pressure. Slope is inversely proportional to pressure. When theta 1 is greater than theta 2, P1, pressure 1, will be lesser than P2. This is because slope increases and the pressure decreases. When the slope is increasing, pressure is decreasing. So this is the property. Using this property, we can say when the slope is more and the pressure will be less. So P1 obviously lesser than P2. That is the answer. P1 is lesser than P2. Option A. Identify the logic gate for the following output: input A and input B. So here the diagram is given, or the logic gates inputs are given, A and B. Here is A, here is B, here is the output of the logic gate. Four options are AND gate, NOR gate, NAND gate, XOR gate. Let's see how to solve this problem. It's very easy. Don't panic once you see the question. Read it, understand it, and write the given data. So with the by writing the given data, you can able to get an idea and proceed. Then you can able to solve the question. Here are the two inputs. A and B are the two inputs of the for the logic gate. Y is the output. Now moving back to the question. Now you can draw the vertical line. This is the time t0, t1, t0, t1, t2, t3, then t4, t5, and so on. Now from t0 to t1, from t0 to t1, A is equal to 0, T0 to T1, A equal to 0, B will be also 0, and Y is given as 1. I am not assuming this, but these values are given in the graph or waveform. Similarly, from T1 to T2, A equal to 0, A equal to 0, B equal to 1, and Y is 1. And from T2 to T3, A equal to 1, B equal to 0, Y is equal to 1. For the next time period, A equal to 1, B equal to 1, Y equal to 0. So this is these all the details are given in the waveform. What does this represents? This is the truth table of NAND gate. Truth table of the NAND gate is given here. This is the logic gate, NAND gate. For example, when A equal to 1, B equal to 0, we should get Y equal to 1. A equal to 1, B equal to 0. The output of the AND gate will be 0, and that is inverted. We get output of the NAND gate Y equal to 1. Similarly, you can able to substitute all the values and verify whether we are getting the right answer. So according to the truth table, it represents the logic gate NAND gate. So our answer is NAND gate. Find the dimensions of self-inductance. 4 options are given. Let's see how to solve this question. E energy stored in the inductor is equal to half Li square, where L is the inductance, I is the current. From this formula, we can write L equal to 2E by I square. Here 2 is a constant, so we can neglect, because we are going to find the dimension, not the value of L. So dimension of L, which is equal to dimension of energy divided by dimension of the current, I square. So dimension of the energy is given as m L square T power minus 2 divided by the dimension of current A square, ampere. I is ampere, so A square. As a result, we get the dimension for L inductance, that is which is m L power 2 T power minus 2 A power minus 2. Here is the answer. But in the answer, they have written L L L square first, then M, then T, then A. No need to panic. Whatever may be the order, it doesn't matter, but the the power should remains the same. So our answer is L square M power 1 T power minus 2 A power minus 2. Option C is the right answer. Match the correct column. X-rays, IR rays, UV rays. Column 2, sterilize, study cubic lattice, greenhouse effect. For example, we know for sure UV rays is used to sterilize. But for example, we don't know the match for the X rays and the IR rays. How to use the elimination method in this multiple choice question. In the multiple choice question, four options are given. Four options are given. Option A, B, C, D. We know the exact answer for UV rays in the column 1. It matches to the column 2, that is sterilize. UV rays treatment for water, drinking water, mineral water. Have you heard about this? UV rays treated mineral water, that is to sterilize, kill the germs in the present in the water using the ultraviolet rays. So for sure we know UV rays is to sterilize the milk or water. So option C is P. Option C is P. There are two options. Option A and in the option B, C matches with P. So we can eliminate option C and D because it's a wrong answer. This is the wrong answer. Out of A and B, one will be the right answer. How to find the right option for the question? So we need to go further to read. IR rays, for example, X-rays. X-rays, when we are X-raying an object, we are going to study the cubic lattice. X-rays is used to study the cubic lattice. That's for sure. And IR rays will be affecting IR rays greenhouse effect. UV rays sterilize. So X-rays in the option A, X-ray is given as R. A is matching with R. A is matching with R. Definitely no. So we have already eliminated C and D. But X-rays, it is given as greenhouse effect. No, we can eliminate this answer. So what is remaining? AQ, BR, CP, that is the right answer. So this is how we have to use the elimination method. If we are not sure about the four option, we can eliminate one by one. Thereby we can able to find the right answer. Find a fraction of current passing through galvanometer given Rg, that is resistance of the galvanometer, is given as 720 ohms and Rs is 80 ohm. Rs is the shunt resistance, 80 ohm. Four options are 0 0.3, 0 0.2, 0 0.1 and 0. Let's see how to solve this problem. Here is the diagram. Here the circle with the arrow that represents the galvanometer. It has the internal resistance Rg. Its value is given as 720 ohms. Rs value is given as 80 ohm. 80 ohm is given. Now using the formula, that is Kirchhoff's current law, at a junction at this junction, Incoming current is I in the left hand side. Outgoing currents are IS and IG. So incoming current is equal to outgoing current at this junction. So we can able to form the equation number 1 using the Kirchhoff's current law. Algebraic sum of currents at a node or a junction is equal to 0. Or incoming current is equal to outgoing current. At this junction, incoming current is I, outgoing currents are Ig plus Is. So equation number 1. Now the potential voltage drop across the galvanometer will be the same. The resistor Rs and the galvanometer are connected parallel, so voltage drop will be the equal will be equal. IGRG is equal to ISRS. From this, Is is calculated as Rg by Rs times Ig. This is the equation number 2. Now substitute 2 in 1, we get I equal to Ig plus Rg divided by Rs times Ig. So I is calculated as Rs plus Rg divided by Rs times Ig. Rg is given as 720 ohm. Here I am sorry, here is Rs. I write Rg, that is the wrong one. Rs is equal to 80 ohm. Substitute in the value in this equation, we get 800 divided by 80 times Ig. Now I equal to 10 times Ig. Ig by I, which gives 1 by 10, which is 0.1 amps. What is the meaning of this equation? The ratio between the current flowing through the galvanometer to the total current I will be 0.1 amps. So our answer is 0.1 amps, option C. Thanks for watching this video. Please see our other videos on NEET, JEE solved question and answers at Vidya College, Winmain. Please don't forget to subscribe, comment and share. Thank you once again. See you in the next video. Until then, it's goodbye from Vidya College, Winmain.